Good afternoon, everyone. Thank you for joining in for what might be yet another Speed 3D webinar. We did a few of these in the summertime, leading up to a Metal AM article that we drafted and put into Metal AM in the summer. We were on with some defence reps back then. I'm pleased to say that today we have another superstar panel. You never just have a panel. It now must always be referred to as a superstar panel. So we have a superstar panel lined up today to talk about the rights repair and all things defence and additive and advanced and digitised modern manufacturing. Before I let my superstar panel introduce themselves, we'll do a little bit of business. I'm Calum Stewart. I'm based in the bonny country of Scotland in Peebles, where I work for the Australian firm Speed 3D. There we are. And we make this sort of stuff behind me here. That's just a deployable shipping container that happens to be a metal additive manufacturing capability. Okay, so allows us to make large, high quality, beautiful bits of metal. And we sell this stuff to defence around the world. So large metal parts, fast. That's what we do. And that's my sales pitch complete. I shan't do another sales pitch for the rest of the show. Okay, so before we get into the conversation, I'm going to hand over to each of my panel members to introduce themselves. But let me just say, I know each of the panel members. I've worked with two of them whilst we were in the military together. And one of them is probably so famous in these circles, he doesn't actually need to use his real name in front of him on a Zoom call. Okay, and I love working with all these guys. Today, the conversation, I've told them, imagine it's Form Next. It's Form Next this week. It's 5 o'clock. The beers have started flowing, and you're saying the things you've wanted to say all day, and you're saying it to the people you want to say it to. That's the kind of conversation we're going for. Okay, so without further ado, I'm going to go down on my screen to the man in uniform, Lieutenant Colonel Dave Reith. Dave, over to you. Tell us who you are, where you come from, and what you're up to.
Hey everybody, so I'm Lieutenant Colonel Dave Reith. I'm a maintainer by background, so REME for those who are UK facing, but ordnance for our US colleagues are wider. It started off on the tools, so to speak, looking after heavy weapons, and I spent a whole career doing that. Then transitioned, stayed in the maintenance space, but over 30 years experience. As an officer, I've specialised mainly in capability development and acquisition. I've spent probably the last 15, 16 years in that world, very much immersed, but in the much, much broader sustainment world, not just maintenance, which has helped a lot. From 2020 to 2023, I was the equipment support, so the maintenance capability lead in Army HQ. So I kind of owned advanced manufacturing for the British Army, which is where I got to spend, a good 3 years working with Howie, which was fantastic. And I think we took it forward a long way there. And then for the last 3 years, I've been based in Fort Lee in America, which is the Sustainment Centre of Excellence, where I've been very much focused on driving sustainment interoperability across the whole of the sustainment enterprise. So everything from supply, distribution, maintenance, repair, recovery. It's the whole of the how do we move from the now largely defunct logistics is a national responsibility, which meant that all of our sustainment systems were designed in isolation, to a world where sustainment remains a national responsibility, but it's designed to be interoperable from first principles. And I think that's very much the area that I'd like to tackle this conversation from. And I'm coming to the end of my tenure, so I'll move on in February, but I'm staying very much in the sustainment world, where I'll move back to Field Army HQ and continue in the kind of cap and act world. That's probably enough from me, Callum.
And for those who don't know, if you're in around UK military, if it's to do with advanced manufacturing, David is basically the compass for the organisation as to where we take this stuff and how we use it. There we go. Right, and then we're going to move along over to the other Dave Reith, the better looking Dave Reith.
The better looking
Dave Reith. Howie, on you go. Where are you
Yeah,
doing?
so
What are you up to?
The American version, even though we're both in the United States right now, we just can't be in the same place because that could cause some just disturbances in the force. But at
That's
any
fair.
rate, yeah. So Howie Marotto, in spite of the title, but I'm honored to be known as Dave Reith for this call. As Dave mentioned, we've worked together for a long time in the advanced manufacturing space, and like Dave, I also started in the maintenance arena. I started out as an aircraft maintenance officer all the way back in the last century. I can't even believe I should say that, right? Back in
Hmm.
1996, I was a Harrier, which is, of course, a first of British aircraft. We talk about
Hmm.
interoperability and sharing systems. I was a Harrier aircraft maintenance officer in the Marine Corps to begin with, and then stayed in aircraft maintenance for quite a few years until I became a field grade officer and then started getting more into logistics writ large. And had the opportunities to serve in Kosovo, Iraq, and Afghanistan in logistics and maintenance roles. And one thing I'd like to say too, and kind of back to Dave's point, is never did I ever deploy where I wasn't serving alongside Brits, right? So in every war, we fought, again, we talk about these national responsibilities, but we don't fight wars alone. It's really not a thing. There may be little conflicts or little bombings and those sorts of things that we may do from time to time, individually as nations, but typically we do nothing alone. So I think it is a very timely conversation. And how I got to this place when I was working with Dave was in 2015. I was assigned to headquarters Marine Corps installation and logistics, and I was assigned as the additive manufacturing lead. So of course that's when I started working with Dave. But very very early on, I would say almost from the beginning, we never looked at additive manufacturing as a single nation solution. We always looked at the value of additive as being able to proliferate machines across the field, being able to use each other's machines to do repair, to do parts. So I think this is a timely conversation. It's always been a timely conversation, and it's
Hmm.
I think a bit frustrating, and I'm glad we're having this forum. It's a bit frustrating. We're still having to talk about it,
Hmm.
and deal with it. So looking forward to the dialogue today, and hopefully we can peel the onion a bit for our listeners and for each other.
Thank you, Howie. On to Darren.
Hi, I'm Darren Kitching. I've spent 2 years working in the additive space, but before that, I was ex-British Army, Royal Electrical Mechanical Engineers, the same as Dave, and I worked in the maintenance space. I deployed operationally to Iraq, Afghanistan, Northern Ireland, saw all the trials and tribulations that were required with stretching out logistical supply chains. And actually, I see what I'm doing now is almost still serving, trying to help defense organizations, which I've worked with around the world, Japan, US, UK, Ukraine, in order to augment their supply chains and become more resilient in the way that they operate going forward. I see this almost as still serving, but in a different kind of uniform.
Yeah.
That's pretty much what I do.
Darren is, I would say, a bit of a special unicorn in the industry. Knowing defence and additive, Darren's supporting and training Australian militaries, the Japanese, the Ukrainians, the Brits, soon to be the Nigerians, the Americans. When we talk about capability and we talk about training a Japanese soldier is not the same as training a Ukrainian, right? It is a big difference to training an American to training a Brit. Darren is working with all of them, and the knowledge that he's acquired in the last 2 years, I think, is pretty rare. There won't be that many with that much experience on the ground, actually learning, is this achievable? Can soldiers, sailors, airmen do this? We're all assuming they can. Dan's probably the most expertise, very few people around the world right now of knowing what that global answer is. So, whilst there's always lots of ideas, Darren's kind of the one that I come to for, Dave, if you're a compass, Darren's the one who's having to use it and decide, actually, is it pointing me in the way I need to go? And then lastly, as an introduction for myself, we have 4 either current or former defence people here. I was British Army alongside Dave and alongside Darren. I was a maintenance officer, just like Dave, British Army for 10 years, and then the Australian Army for 3 years. So I'm equally passionate about the prize. The prize is more kit back in the fight more of the time. Okay, and the idea of deployable digitized manufacturing is just another tool to help us achieve that prize. That's all it is, and it shouldn't be anything new or difficult. Anyway, that's the introductions. Please remember, if you've got questions, stick them in the chat. Okay, don't put them in Q&A. Q&A is difficult for me to look at, and I am not only host, but I am the producer behind all this with my magic digits. So please put it in the chat. It's easier to see your questions in the chat. All right, so it's Formnext this week. So everyone's all juiced up and additive. There's lots of political happenings, probably more US side, but also in the European. So I could say in the US, right to repair is becoming very popular. Politicians talking about it. Okay, it's no longer acceptable to just wait for the defence supply chain to come up with an answer. We've got the regional sustainment framework in US policy talking about how do we sustain forces globally at reach. And then we've got European, the SAFE programme, European defence programmes putting hundreds and hundreds of billions of dollars into defence, a good portion of which is going into sustainment. That's big money. So there's business opportunity for the people on the call here that are involved in supporting the defence enterprise or part of it. I'm going to come to Howie first, then Dave. Give me a short, because we've got half an hour left. Give me a short summary of state of the nation, where we are. You're right, Howie. We've been talking about this too long.
Yeah.
Okay, and not moved far enough forward. So give me your thoughts. Where are we today, 2025, and what can we do better?
Yeah, absolutely. And I'd be remiss if I didn't also mention my current job, which is I'm with the Barnes Global Advisors, but I'm also still a colonel in the United States Marine Corps, 32 years in, and I'm assigned to the Office of Naval Research. So while I'm speaking today as a civilian, obviously I'm still in the military. But yeah, where we are now, we've made some progress. I mean, the fact that the narrative to right to repair is so prominent in American media right now, and with the Secretary of the Army. I think that shows that people are finally starting to listen to the message that Dave and I have been saying for many years. We've got to figure out how to do better, how to keep our weapon systems in the fight. How can we help our allies and partners do that? Ukraine has really brought that to light, and both nations have played a large role in that. But I also think there's a lot of trepidation, right? As there has been through this whole conversation with additive manufacturing and IP. The industry, again, on the American side here, has pushed back very, very hard on the Secretary of the Army. I think there's misunderstandings on both sides about what guys like Dave and I are trying to do and where we're trying to go with this, these capabilities, including additive manufacturing, to keep weapon systems in the fight. So I think while things have progressed, I think we're coming to a culminating point. And you're going to see a lot more debate about the subject of right to repair, a lot more debate about additive manufacturing, a lot more debate about IP as it becomes more prominent in the public conversation. And what I hope is, and I hope this webinar can help resolve to some extent, is we're not at odds. We're not at odds with industry. We're not at odds with the warfighter in the field. There is absolutely a solution out there. If we're wise about how we approach it, and if we put the emotions aside and actually talk, get down, as we would say in the U.S., to brass tacks and talk specifics, and I think we'd find we're a lot closer together. So I think we're getting there. There's a meeting at Formnext. Speaking of Formnext, today, with all the AM leads for many of the NATO nations, and we're talking about how do we use additive across NATO and even beyond NATO. To support each other. So I think, again, we're getting there, but the mechanisms just haven't been put in place, at least not many yet, in my opinion.
All right, Dave.
So I'd agree completely, with Howie. I think in terms of where we are, if I look back, 5 years, I think we really have made really, really positive steps, If we look at the capabilities that have been deployed elsewhere in the world, to support, for example, the Ukrainians in this kind of space, you can see that there's a realization that this kind of approach can transform how we think about maintenance and repair in a warfighting scenario in a really positive way. I'd posit though that for me there's two sides to it, and it started with supply chain replacement. And I think the Sec Defence's right to repair comments really reflect that. There's a realization that advanced manufacturing or manufacturing per se can provide resilience to the supply chain, and I think that's what the Sec Defence was trying to get after. But I think some people saw that as a replacement. It's 100% not a replacement for the supply chain. We need resilience in the supply chain when you're war fighting, and that's what this provides. But I think where we are now, certainly within the trilateral that I work within, so UK, US, and Australia, so we're working really closely in how do we unlock this, and it's about battle damage repair. And that's really about how do you democratize access to our most expensive resource, and that's our really, really expensive, tradespeople, our CW5s, our ASMs, our engineering officers, our chartered engineers. They're a really rare resource, and each and every time they look at a battle damage repair, it's really expensive and time consuming for them to design, repair, manufacture it, and then embody it. But actually, by using digital technology and then whether it's advanced manufacturing, so if it's 3D printing of parts, cold spray, traditional arc welding, machining, it doesn't matter. How do they all come together, digitally captured to effect a repair? We can do all that really quickly now and share it across the whole of the force, which means you manufacture in a distributed way. You can off-site your design, you can off-site your assurance in a way that was never previously possible in a warfighting scenario. And that means that you can get more repairs out of the same number of people without any additional training. You can just use where they are at the moment and affect it because you capture it, you bottle that wisdom in a digital file that's worth, it's invaluable. When you're a operational commander in a tank and you need to get it back in the fight, if you can get it back in the fight using your existing tradespeople, it's almost impossible to put a price on that. And we can do that every day in peace. And we can learn from, our partners and allies, such as, the Ukrainians or anybody else who's in a conflict. You do a repair, you capture it, it goes in a dynamic digital catalog that's accessible to anybody that you want to share the information with. So
5 years ago, you came to me at DSEI, Dave. I think it was 5 years ago, and you said, "I don't care about the kit. I can print the world. Look around. I can buy it all, and I can print the world. It's the data." Correct. And at that point, I was still a rookie to all this, and I wasn't following you really. If I'm honest about it, I didn't get what you were on about the data. Now I get it. If we have the data, we are so much quicker at effecting repairs, which means we outpace. It's all about outpacing an enemy, right? We want to be able to outpace the enemy. And if we slow ourselves down with the proliferation of data and arguably the doctrine that allows us to use parts. So if we're going to hung up on how we make a part rather than how good it is after we make it, I'm going to posit we're going to be slower than the enemy. How we make a part, I frankly don't care. I care about what it is after I've made it. And we get hung up in that. So the pace at which we engineer, the engineering OODA loop, for all those military geeks out there, how quickly we can understand our problem and change it and affect a solution is hugely important. But then, Darren, you're out there on the ground with all these troops, training them.
Yeah.
What is it that you see that's good? What is it that you see that should concern us all?
Actually, the operating of 3D printing systems is really, really easy. Interfaces, understanding, and you're working with guys from technical backgrounds, so you don't have to train them from scratch. You just need to augment what they already know. I come at this from a slightly different place. For me, it's not about getting kit back in the fight. For me, it's about saving lives. And how do you save lives? By getting the equipment that protects those lives within the warfighters. And we've already done this for years and years and years. When I was a private soldier, I'd be upside down in a scrap metal bin looking for the right bit of metal in order to get a file, in order to make a bracket to fix a Land Rover or whatever it was. So this is nothing new. All that's happened is the technology has changed. And the biggest hurdle we have, like Dave said, is actually the data. But what we also know, especially within NATO countries, is the soldiers are very resourceful. So the data can be provided by an OEM and they can monetize that through lots of different means, whether it's a cloud-based subscription service, whether it's a pay-and-play service. And there's lots of ways they can do that securely. But at the end of the day, the ASM, the Chief Warrant Officer 5, all he wants is his kit back in the fight, and they will adapt and they will learn how to reverse engineer and replace these parts, even if they're not supported by the OEMs. And that's the biggest hurdle at the moment, but it's not difficult to overcome. When I left the military, I hadn't touched CAD since 1998. And by then it was plotting points in space and drawing a line. And it was, it was a green screen computer that we were doing it on when I was at the apprentice college. In pretty quick order, you can teach someone how to use CAD. I did it on YouTube initially. And then from there, I'm now reverse engineering parts. And there's parts that I've reverse engineered that are now on bits of equipment that are working operationally in Middle Eastern theatres. So the military will be able to do this. I know because I can do it. And I'm ex-military. I'm the same as the people that would be operating this kit. And training them, the NATO military especially, they have the right mindset. It's, a couple of weeks of training. We do a, crawl, walk, run sort of program, and they're up and running. And all of a sudden they're coming up with ideas that I've not even thought of. Dave's not thought of. Other Dave hasn't thought of either. So, the military are going to do this because.
Yes. All right. So the military are going to do it. Are they? Do we still have in enough quantity the engineering courage to do the things that we four think we can do? We all think we've got the courage to do it. Do our defence organisations still have the engineering courage to be artisans, to go out there and say, right, I'm going to make something and just go use it? It's okay for the defence of the Secretary of Army to tell me to go do it, but do I have the courage to do it? How are you laughing or you're grinning?
Yeah. I mean, that's a brilliant question, Calum. I've never heard it put that way. Do we have the engineering courage? A lot of times I talk about intellectual courage versus physical courage. And it's often it seems a bit odd, but in the military we have a lot of physical courage, but often at the engineering level we don't have a lot of intellectual courage. As Darren said, hey, you're going to do what you need to do in the field. I mean, we've all seen it, at various points in our career. I remember when I was first talking about additive manufacturing, and this goes to your point about engineering courage. Very first conference I ever attended that I talked about additive manufacturing back in 2015. And I did not know the program manager for MRAPs. And for our listeners who may not know what MRAPs are, they're the up-armored vehicles that the military used to counter IEDs, to protect soldiers and Marines from IEDs. And eventually every nation was employing them in combat zones. The PM was there and he was saying he felt angry when I talked about soldiers, or Marines repairing these in the field or using additive manufacturing to do these repairs. And then he went through the phases of mourning, I think. And then, then he kind of became resigned to the fact that he's not going to stop this lieutenant colonel from saying what he's going to say. And then finally, he had an epiphany, had acceptance of it. And he came up to me afterwards and he said, listen, every single MRAP, he's like, I was angry, but every single MRAP that came back from Iraq, this was during he's talking mostly around Iraq and then a little bit of Afghanistan at the time. He said, every single one that came back had modifications done to it, every single one. And sometimes they were good and sometimes they weren't. They were never uniform, right? And he said, I see additive as a potentially great promise because the power of additive, because of the sharing, because of Dave's point about the data and Darren's point about the data, is that once we find a good design, a great repair made in the field, then we can share it across the services and share it across the nations. I mean, if you look at what Ukraine's doing very successfully, and by the way, the Russians are too, they're putting engineers at the front, and then they're feeding that information back to the factories and making modifications on the fly. But do we have that courage? I don't think we do yet, but I think we're getting there. I think it's going to take a lot of pressure from the top as well as pressure from the bottom. The folks in the field doing reverse engineering. I mean, right at Fort Lee, where Dave's at right now, we train our U.S. Army machinists and Marines to do reverse engineering with scanners as well as with calipers. And this is something we've been training them to do for years, just like on the British side. So we've always had the capability, but the engineers have always been afraid of it, and industry's afraid of it. And so what we've got to figure out is how do we bridge that gap so that there is more engineering courage and we have risk acceptance in the field, but how do we get that risk acceptance at the engineering level? I think that goes through the data, right? Again, not only data for how do we manufacture that component, but data that helps us validate the goodness of it, or maybe just the temporary nature of it. And then getting everybody on the same team. And it's not easy. That's going to be the biggest hurdle, I think, is getting that engineering courage.
Yeah.
Dave, interested. What do you think? Engineering courage.
So I'm quite optimistic. but I think it's very contextualized. You know, I think anybody who's been in a warfighting zone, nobody will have approached, you know, a maintainer of any, you know, nation and said, "Can you repair this?" And they'll have gone, "Well, I could, but policy will prevent me." As Dan said, soldiers do what soldiers need to do to win, and you know, remember that the only role of armies is to win. You know, which is why, you know, policies and rules and stuff, when you're being shot at and lives are at risk and there's a risk that you will lose, all of that goes out the window, because you're the number one overriding principle and policy. The only thing you have to look at is how do I win? And soldiers understand that at a level that I think, you know, we should, you know, should take great pride in. And that's, you know, the current generation of, you know, tradespeople and soldiers are way more technically adept than I ever was, which means they'll be able to do more. I think the challenge, though, is the perception. You know, what can we allow people to do? And actually, that's what I'd call the challenge we've got currently is lots of our policies and our training bills and the way we structure our forces and deploy them, they're designed in and around support to training, which are very rightly designed to protect life in peacetime, because it's not acceptable to lose lives training. So we've got this tension built into the system where our military platforms have got to be assuredly safe as they were when they were designed and manufactured by the OEM.
Yeah.
But we need to create the space and the envelope that lets our young engineers and tradespeople understand that when they go to war, all those rules they're off. Which means every training opportunity we've got to inculcate this kind of approach to how will you fix it. And a lot of that's, well, how do you, because currently we can do it and we know we do it. You know, we've got amazing tradespeople who are deployed all around the world and they'll fix stuff. The issue is they do it once, they repair it, it disappears. And quite often, because they'll, you know, whether we like it or not, some of them will do stuff that isn't 100% policy compliant, but because they think they're doing something wrong, they won't tell anybody. But even worse than that, the gold they've created, that wisdom they've created in repairing that platform when nobody thought it was repaired, is lost forever. And that for me is the real crime. Whereas if we're able to capture it, so if you imagine a world where every training opportunity you encourage them to repair it. Now you might not use that repair, but you've
done the work.
You create the file, which means you've got a dynamic library of repairs that exists through time. You can then take it to industry. And How's Point's really good with the MRAP. You know, it's how do we help those people who own the policies and quite rightly want to keep all of our soldiers safe for really good reason. I've got absolutely no argument with that at all. So we can prove the value in training and peacetime and create a framework that helps us better let the defense industry, both, you know, green and civil, understand the value of this approach. And as you start to go through that cycle, the real value of it in a warfighting context really comes to bear, but also in a support to training, because people will just become more comfortable with using, you know, traditional manufacturing techniques. So I always think, you know, I think that the high watermark for me would be around 1945. I could not go in a single regimental unit, line, or anywhere or any echelon and not have a whole load of users cannibalizing equipment to keep the kit on the road. So from users all the way through to, you know, industry deployed on the far bank, where you've got cannibalization, salvage, reclamation. These were all routine things that happened at every level because everybody understood that these are the things that you've got to do.
You were desperate.
Now, uniquely, unlike 1945, we can capture digitally every time that we do it, which means I don't need a chartered engineer to make a decision the second time I do the same process. I now just need an incorporated engineer. And when you've done it 10 times, do you know what? It's just a technical publication that a 3-year tradesperson straight out of trade school with not much experience, they just follow the YouTube digital file steps 1 through 10, it's done. So you reduce the cost of repair, you maximize the amount of equipment that's availability, you reduce the cost of the people that you need to do the repair, which means everybody moves up the value chain and we can make that happen now, you know, at a lower tempo than we would in warfighting. So I'm optimistic.
we're half an hour in, half an hour to go. Let's say we've got another 15, 20 minutes of discussion. Questions, please throw them into the chat. If you're not using the chat, throw in the Q&A. Throw some questions in there for the last 10 minutes. Right, so we can print the world because we've got all the kit, right? The kit, there's so much of it. We know we need to manage the data, but actually the software exists to do that. We know that our people are generally courageous enough when we take the brakes off, right? When we take away the barriers to action, they're engineering and they're courageous to go use it. So it feels like all the ingredients are there. And yet when I walked around Formnext yesterday, my industry, my peers, competitors in the industry don't talk about it. You walked around Formnext yesterday and it felt as if people only make turbines, right? In the metal world anyway, right? Everyone's got a fancy looking engine, rocket engine, turbine blade, that was it. And I'm walking around going, I mean, that doesn't personally excite me. I'm more interested in what we're discussing now, more kit in the fight more of the time. And part of me thinks, my industry now, my new industry, we fail because we are 3D printing companies. But to affect what we want to happen here, we need to start becoming defense tech companies and understand our role is as defense tech or defense capability companies. If we want this stuff to happen, the Speed 3Ds and all other companies in the world need to start speaking the language of defense and understand where we fit in this map and the laydown and how our kit's used. I don't think we do that particularly well yet. But there's probably a reason. There isn't any money in it, right? There's no money in it yet for people to move. So I can't look at the list of participants right now because I've not enough fingers and not enough eyes. But I'm going to gamble on this list right now. There's other companies like Speed 3D. And they're sat going, we've probably heard a lot of this before, right? We've been saying this stuff for probably the last 5 years with this enlightened panel. Where's the money? Where's the opportunity? How do we get defense politicians, government primes to go and actually pay some attention to the technology that's out there and understand that it's valuable? How do we get them taking interest instead of drones, right? If you're in the drone business or quids in, no one's looking at manufacturing for sustainment.
Well, I think there's a couple of ways if I can jump in.
Yeah.
Because obviously, and I don't know if I can share a screen, but there's two ways. I have a slide, but I can just talk to it.
I wouldn't know.
Yeah, I can talk to it.
Yeah.
So there's two ways. One, and again, I can't speak for the UK and the acquisition policy there. There's a lot of acquisition change coming in the United States. I haven't been able to comb over it in depth, but I've seen some of it. But what we have to do is incentivize advanced manufacturing in support of sustainment. And what I mean by incentivize is when you are bidding on the next combat vehicle, right? As a vendor, your proposal will be rated higher or lower by how much of that vehicle can be additively manufactured and how much of that IP is available. And then, you will outcompete your other bidders because your vehicle is 80% potentially produced with additive manufacturing. It could be interchangeable, right? There's a term in the U.S. Navy now called interchangeability, where they're talking about with the shipbuilding industry in the U.S. to be able to make a part either with additive or with conventional manufacturing. Doesn't matter. As long as the same materials and meets the specs, you're fine. That nobody's going to provide, create different standards for one or the other. So that's going to help with it. But I think, again, incentivizing the folks to come out to do it up front as part of the design, and then awarding those people those contracts. I think that helps, one, because then it becomes more profitable. Two, I think, because otherwise they're just going to do things the way they've always done them. And then you're going to be in the same situation we've always been in. I think the other piece is understanding the law. I mentioned earlier about right to repair. I actually, in all due respect to the Secretary of the Army, I don't think his lawyers are advising him well. In the United States, we have Title 28. And anybody can look it up, Section 1498. I didn't just come up with this and I didn't Google it. I was taught this by a patent attorney, one of the best I've ever been around, who was one of the leading IP attorneys in the Department of Defense, now Department of War, before he retired. Essentially, since the 1920s, since World War I, the United States has grappled with this, right? Between industry and defense. And essentially, the United States military has the right to repair anytime they want and reverse engineer and do whatever they want, whether industry likes it or not, violate patents, do everything else. As I mentioned for all the folks on here, in our U.S. Declaration of Independence from you guys, which I'm sure you're grateful we're independent now. You wouldn't want the problems we bring, but in there we talk about how men are endowed by their creator with inalienable rights. The reason that was put in there was because if something's given by the government, it can be taken by the government. I like to remind vendors of that. Mm-hmm. If the government issues patents, we can also violate your patent, and we will in times of war. But that's a negative message, right? And I think that's the negative connotation that's out there right now. I think we have the technology. Back to the data. It always goes back to the data, Dave. And I this is an overused example, but it's actually really available. The music industry at first was freaking out with Napster, right? And then they were freaking out with all these other, these sites where you could take and download their music. Now every artist gets a royalty fee every single time one of us plays a song on one of these music apps.
And they've never been richer.
Right. And so how do, the manufacturing industry has struggled to wrap their heads around this, but it's not any different. It's just moving packages of data. Now there's more data than just the print, right? There's more data, but that doesn't matter. You put a value on that data and you sell it. So you license that data. And I think and I'm sorry, it's a long way to get there, but I think it's a complex answer that we haven't really wrapped our heads around, but it's really not that hard. We use the same technology that's out there to move data right now and monetize that data through royalty fees. And we write that into our contracts with industry. So every time a soldier, sailor, airman, Marine, Guardian, whomever out there, or another nation, by the way, doesn't have to be our own, prints that component out or that item out, they get a royalty fee. And that's how I think we incentivize it.
Yeah.
It seems it's so bloody obvious, right? But why is no one offering it? Why is it when, and this is part of my job, I try and bang on the doors of the defence primes and saying, here is the opportunity to generate, up until now, unrealised revenue.
Yeah, no, so I'd agree completely with Howie, and I'd probably frame it in this way. You mentioned before that years ago, when we were talking about it, and Howie and I, I know that Howie's completely aligned with it. It's got nothing to do with the tech. Speed 3D make, manufacturing capabilities. So people think that it's about the tech, but it's got nothing to do with the tech. The tech's it's the vehicle through which I can see what you do. But because people like shiny things and they like tech, they become fixated with the tech. But the value, so what I'd call it's digital wisdom. That's what it is. This is what it offers. People are our most valuable and scarce resource. And you go, why is that? Well, because people can make magic things happen that people don't think can happen. And that's especially important on the battlefield. When you've got an MBT or an Apache or whatever it is, it's a bit of kit that will keep you safe and make you win. You need people who can keep it in the fight. Now, currently, the only people who can do that, it takes me, 30 years to train a CW5. It takes me over 20 years to train an ASM. It takes me 15, 16 years to get a chartered engineer, which means when we go to war, there isn't going to be any of them anywhere, and they're going to be like even scarcer at the point you need them.
Mm-hmm.
But the wisdom that they create every day when they're doing their job, we can now bottle it digitally, and then we can democratize access to it. So I think that's once you've done that you then start to get help industry understand that this is not about supply chain replacement. This is about resilience in a war-fighting system of systems that will make sure we win. Because if and when we go to war, if we lose, there is no industrial base. There's all of it disappears, overnight. And I think, so I think the big decision makers, I think they understand it. You got the Sec Army talking about right repair, which means he understands at a fundamental level.
Mm-hmm.
This is important. Perhaps not what it is. What's the thing that he's touching, the value, and I think it's digital wisdom. And I think Tempest, so I'd highlight that, so it's probably going to be, Tempest is the next generation British fighter in partnership with the Japanese. When they announced that program a few years ago, one of the big ticket items that kind of passed people by was they committed to a minimum of will be additively manufactured, because they recognise the not just the benefits to the military, of which there are many, but also the benefits to them as a defense industrial supplier in terms of redesign and modification and manufacturing globally. So there's, I think everybody gets it, but you're right. It's how do you bottle it in a way that helps people understand it, and it's, for me, it's never been about the tech. It's about the doors it opens and all the resilience that you get in a system of systems by having something like this.
Yeah. As you were talking there, the word relationships kind of popped into my head. So let me see if this. I was at the NATO Industry Forum 10 days ago, and at an event where it was chock-a-block full of all the CEOs of all the big defence primes, discreetly, as you do when you're 6'10" with great hair, and all anyone wanted to talk, well, quite rightly, what they were talking about was money. No one's going to invest anything unless someone's going to give out money, right? Or someone's going to pay for it. And particularly if you're Europe, or sorry, if you're NATO, right? NATO now is kind of like NATO in Europe, and if we're lucky enough, we get the United States to help us as well. But NATO in Europe right now is worrying about how it sustains itself. Where does NATO in Europe get its money from? Where do all these nations get their money from? They generally get it from the European Central Bank, right? So for NATO to be effective, money must come from the European Central Bank, and it's coming in hundreds and hundreds of billions. But the great point was made, that money has to move quickly down, right? It has to pass from government to prime to subprime to other prime, down, from business to business to business to business, just so you can get the widget. So that bottom at the company at the bottom of that pile of suppliers that supplies the one widget that must be used must receive capital in time to still be alive by the time it needs to deliver the part. And without that one part, all these other guys are freaking useless. So the flow of cash is really important, and that's no different for our industry. Okay, you look at the accounts of our industry, right? Even the big companies, unless you're Chinese, right? It is not an easy business to be in, even for the big AM industries, big AM companies. Harder even for the little guys, even like us at Speed 3D. Cash is king, always. Relationships ensure the flow of fast money. So let's say the businesses on this call, how do they go about garnishing, creating, building trust in relationships from business to defence so that they've got a chance? I know a company told me yesterday, they've been in the gig 5 years. They've been courting UK MOD for 5 years with wonderful kit. They finally got their first deal, but it took 5 years for a couple of £1 million. That's not sustainable. We've got to be putting more money into this. To do it, you need the relationships. That's 5 years of relationship building. So that was a bit of a rant that took me on about relationships and the flow of money and making sure our industry survives. Give us your thoughts on that. Anyone?
I'll defer to Darren and Dave first. I've been talking a lot, but obviously I have some thoughts on it. But
Darren, what do you think?
So there's a couple of ways it can proliferate down. So at the moment, there's big gaps in the AM industry about different ways of doing things. And I know it goes against what Dave was saying, digital data files and everything, but actually we're saying Tempest is going to be 30% additively manufactured. We don't know if that's going to be on an FDM printer, whether it's going to be on a powder bed fusion printer, cold spray, wire arc, whatever technology. So the industries, although we're bracketed as additive manufacturing, it's a bit fragmented, and it's, there's little niches. When they think of metal, everyone thinks it's some kind of laser. Actually, there needs to be cooperation within the industry as well. So delivering a suite of packages rather than one company competing against the next. If you could create something where you buy 3, 4, 5 metal containers, inside those you have a broad spectrum of both additive and subtractive technology, that becomes a lot more interesting to defense. But it also becomes a lot more interesting to defense primes, because they can then market that as a capability that can be utilized and trained and supported, whether it's as a forward operating service bureau that's done as a service for the military, whether it's operated by soldiers, or whether it's a hybrid of the two.
So do the primes ultimately need to own this? The big defense firms, do we think they eventually need to own this?
I think they need to support it, not necessarily own it. In the short term, otherwise it won't be there for the long term. So, and they'll have to start from scratch in order to build this up when they're doing something like Tempest, when the next main battle tank comes around and it's 50%, 60% additively manufactured, repairable.
Tell you the danger, like if you're in the 3D, if you're in this business, if you're on our side, right? The danger is the primes see the value and then decide they're just going to go make their own way of doing this. And then the little guy, the industry that's been trying to help solve this for the last 15, 20 years is slowly going to disappear. That's a real concern for all of us, who are trying to make this kit or provide the software. That the industry actually we get gobbled up by, and you could say that's capitalism, but the big fish decides to go and do it. If you're lucky, you get bought out.
Yeah,
if you're lucky.
So again, I'm relatively
optimistic.
I am optimistic. I'd highlight, so in the UK certainly, and and you look at, I think the US acquisition system as well has very much in the last few years identified that it needs the small and medium enterprises to survive. They've got to be there. That's where the innovation comes from. So they're investing there, and certainly through certainly the land industrial operating strategy, and then if we listen to what the Defence Secretary in the UK said, a huge amount of the total investment is going to go to SMEs. And then I'll just highlight one more thing. Under defence reform, the creation of the Nuclear Armaments Director. So if we ignore the word nuclear in it, effectively it's going to bring together in one organisation all of the UK military's acquisition, so the DNS, the Defence Enterprise and Support, that kind of work, but also the programme space. Which means rather than each of the single services, land, maritime, and air, working out their own different approaches to all of these common problems, that we're much more likely to have a single voice, a single direction, which means it's much less complex, much simpler for industry to A, follow the money, but B, also understand what it is that we're trying to get after. Which means you have a single front door. So hopefully, I am optimistic that it will, it'll help all the SMEs, because I'm absolutely convinced that that's where the real innovation comes from. Will big industry then, consume some of those smaller enterprises? Well, 100%. But hope if a portion of the pie is always dedicated to those SMEs, even if the big industry consumes one, it just means that there's now space for a new one to emerge, which is equally, that's as important as looking at the existing SME enterprise.
Yeah. I'm just one quick comment. I'm somewhat optimistic like Dave as well on this one, and I'm not generally optimistic. I think that, industry is going to have to work with the small guys, and here's why, right? They may incorporate some capability in-house. The military is going to incorporate some capability in-house, do some manufacturing. But, the margins on that a lot of times are pretty small. And even if they do incorporate it, maybe they might put a small mom and pop machine shop out of business outside their, gate. But then at the same time, they might empower a SP3D or another equipment manufacturer. But here's how it's going to have to happen. And here's what we may have danced around it a little bit, but I think here's the reality, is that they're going to have to, and the government's going to have to get involved, because we are losing suppliers. Nobody knows who the suppliers are beyond tier one. And I say nobody, I mean, the military doesn't, the primes don't. I mean, I'll give you a great example from the US. I'm going to throw the United States right under the bus right now for everybody. I'm sure there'll be some happy Brits. But it affects you guys too. So we had a fire in Philadelphia in February. The only aircraft fastener manufacturer in the United States, titanium aircraft fasteners, not a big deal, right? Little part. It burned down. The industry went nuts. Nobody had fasteners now. Why was that? How did they not know that? Because they were all going through distributors who were all going back to the same factory, because the factory didn't sell them. So now the United States aerospace industry, and I think Airbus is affected as well, right? It is trying to find fasteners. And where are they going? China, right? And this is the problem. This is why I think small businesses will survive, but the government's got to get involved, as the military does too, because we're about ready to lose one of the last desktop 3D printing manufacturers in the United States potentially, right? We're on the verge of it. And because China's been putting these companies out of business. So I think once the primes realize that there are no more small businesses to go to because the government and the primes have let them fail, and through distributors secretly, unknowingly, in many
Yeah.
cases, been going to China. It's going to be a wake-up call, and it's going to actually, I think, empower companies like Sp3D and other machine OEMs. It's going to empower some of these small businesses who are just barely hanging on, or some folks who are willing to start up. But it's going to require the primes to recognize, who actually supplies their parts and where they actually come from if you go down past the tier one, and the governments to realize, hey, I'm not a protectionist guy. I'm not a big fan of regulation, but if you're competing against China in the industrial sector and manufacturing sector, they don't play fair. And our governments are going to have to realize that we can't play fair either. And we're going to have to incentivize and work with and protect our small businesses. And primes are going to have to do that too. And I think so. I think, we're going to have to either learn the hard way or get ahead of it. And AM is going to be a part of that solution, but it's going to take some recognition of the problem instead of just, putting our heads under the covers and pretending the ghosts aren't there.
We're quickly going to jump to questions. I'm sure I saw an email from UK Gov, quite recent. I'm sure they're starting a database of defence suppliers. The email comes out. It isn't the most enticing email for you to register yourself as someone who wants to be in the defence supply chain. It's a standard UK government email, right? It doesn't go into the fact that, hey, we need to know who our suppliers are, because in time of war, and we need stuff, we are coming to you, but only if we know who you are and where you are and what you can do for us. The email isn't anywhere near as enticing as that. And then you hear, like, I heard from the head, what was called, he was called the head of international for Airbus at this NATO forum. He said, Airbus, 10,000 plus suppliers, 10,000 plus suppliers. That's just Airbus. If UK government wants to understand every possible defence supplier that it could have, it's going to take more than an Excel spreadsheet, right? I don't know how to solve that problem, but it's more than an Excel spreadsheet. Or a thumb drive to be left on a train somewhere on the, from London to Bristol. Anyway, right, we'll move to question. So we have a question here. I'm going to read it out. So forgive me. In terms of collating the data from field repairs, so that this knowledge is not lost, has any data compilation been conducted to understand components that repeatedly fail, so that data files to field repair these commonly failing components are available? So if I'm mashing that up. So I think as I get that from Rebecca, that's about, do we know the stuff that breaks? Do we have the data so that we can do this better and smarter? Dave, I know you're going to love talking about this.
So certainly from a UK perspective, and I've had quite a lot of exposure to the US. The answer is, in all our big battle winning platforms, generally yes. And I'd say that there's it's in the prime's interest to work out how we manufacture those parts, but then there's a tension between how do they maintain their existing supply chain while diversifying to one that meets the needs of a war fighting force. And those things are not always, they're not mutually supporting until you transition through conflict into war fighting. So I think that the data is there. I think the trick is working out, how do we get, for me, it would always, I'd always go back to that. How do we make sure we win? So I would do probably more modeling on our battle winning platforms to understand which of those components will definitely be damaged during battle damage repair, because then you can prove the value chain in reverse engineering them now. So you address the fact that it's the most commonly failing part, which means if you're able to distribute manufacturing, you get a support to training benefit because you haven't got to wait for parts. But you also know that the corollary benefit, the really, really important one from my perspective as a warfighter, is that you've already got a design on file for when the thing needs to be repaired in war fighting, when the component will still not be available.
Darren, when you're training these military organizations, where do they go to find the things that they need to manufacture? Where are they finding the parts that they should be making?
Normally it's just from their own experience. So there isn't this playbook of parts that commonly fail, but actually most of the people that you train, they've worked on the same platforms for years and years and years, especially for sort of the corporals and the sergeants and above. So they know the platforms inside out, and they know what's good and what's bad and what breaks and what fails and what's likely to be damaged by someone colliding into a hangar door. They know all that information because they've been living that life for years and years and years. And generally what they do is they'll go and point at stuff and say, can we do this? Is this feasible? And if it is, then we usually take it off. We do a bit of reverse engineering on it, and then we try and print it. The biggest hurdle they have is the classification of parts at the moment, because a lot of people get very hung up on how do I certify a part to be used, because there isn't the framework there in order to give people the top cover in order to innovate and create these new things in a clear, concise manner. We can use battle damage repair, expedient repair legislation and doctrine. So most of the stuff they come to me with what we would classify as green parts. So if it fails when it's additively manufactured, it's not going to kill someone, is the crux of it. It's, you know, it's a bracket, it's something ancillary, which at this stage I'm quite happy to do, because what we need to do is we need to get defense comfortable with using things that haven't come in a nice packet from the original manufacturer. And there are other ways to do it. And once defense becomes comfortable with that, then it will start pushing the boundaries and go into these amber parts and eventually red parts, because things have been proven out.
Yeah.
And
so go ahead, Dave.
So it was just on Darren, you made a really good point about the in a support to training role where you're effectively replacing parts that have already failed. And I think people forget that, because you go, well, did it fail safely? And if the component failed safely, component failure isn't actually your issue. It's the mode of failure. So all you need to understand is the new component that you've designed through a new manufacturing technique, is the mode of failure likely to be the same? And if it is, there's no risk, because you already know it failed safe, because it failed. So we shouldn't be trying to replicate the same part with the same testing and everything as we do with OEMs. It's all about what happens when it fails, and then what's the mode of failure. Now, if it's likely to fail in a completely different mode, then you do need to do more testing. But it's a very different approach to how you manage risk.
I love that. Mode of failure makes immense sense. I'm going to steal that from you, Dave. Thank you.
Engineering courage and mode of failure, two things you're stealing from the show.
Yeah, I'm absolutely stealing that one too. And policy, as Darren said, will enable engineering courage if the folks are willing and able to take risks. But kind of back to the question real quick, a little nuanced from both Dave and Darren's answer. So do we know on the major weapon systems, the major components that fail, and generally how often they fail? Yes, that's actually cataloged well. What we don't know are two other things, though. We don't know when they're going to fail in different conditions. And the first 3D printed part metal part ever put on a U.S. military weapon system was on Marine Corps tanks, M1s. It was a vane axial fan. Those tanks were made to fight in Europe. They weren't made to fight in deserts. So what fails in Europe isn't necessarily the same thing that fails in the desert. So we were seeing these fans fail all the time and had huge demand for it, which was never anticipated. So we have to remember the regime we're putting the system into is going to change, and actually combat's going to cause different failures than peacetime too. And Ukraine shows that, right? I mean, I saw an M1 in Poland with the turret sitting next to it. I don't think we anticipate the whole turret blowing off, but it happened. I saw it. Tank guys should all be scared, and I'm sure they are. So, but we're kind of back to the other nuance is sub-assemblies.
We've got 1 minute, Howie, and then I'm having to drop
sub-assemblies. Sub-assemblies. People don't know what those are. There's a lot of opportunities for AM in the sub-assemblies. So, and we don't know what those are. So we got to get better at cataloging that.
Well, we're going to finish in 1 minute. I promise everyone, but they're all still here. They're all still listening. So we're doing all right, chaps. Water is not the same all over the world. That was another thing which I've learned, in the last couple of years. So we're very land focused here, as people here on the call. But if you're making additive or replacement parts for the maritime, submaritime world, salt water at sea level is very different to salt water 100 meters down in one part of the world, another part, and metals react completely differently. And so it's even to a greater extreme than we're doing it here in land. That's been an hour, and we could probably talk for another hour. And I like the new hair. Semper Fi, Howie. Great panel, gents. From some chap, Ryan. Well, thank you for your comment. I appreciate it. I don't. It's unfair making Howie feel that uncomfortable, but on that topic, but that's okay. Right. It's been a wonderful hour. Thank you to our superstar panel for coming along. Hopefully those that have been watching have been informed. They've learned something. If you need to reach any of these guys, they're all on LinkedIn. So you'll find them on LinkedIn. You'll find them from the Speed 3D LinkedIn posts. You can get them on LinkedIn if you need their expertise, if you want to use their business, if you want to buy their kit, awesome kit. We're all available on LinkedIn. Gentlemen, thank you very much for your time this afternoon, for your expertise. When I press the button to turn this off, we all disappear into the ether, so I don't get a chance to say thank you. It's been another cracking Speed 3D webinar. Thank you for your thoughts, your input, and thank you to everyone that's hung around to watch. Have a good day, everyone. Get back to work. There we go.
Thank you all.
Thanks, everybody. Take care.
Bye now.
Thank you.
Bye.